Hello everyone, AFS Log here again, and in this section we will be talking about programming CNC Plasma cutting machines using Fusion 360. Now, there are quite a number of tutorials on YouTube that covers this same topic, right? But today I would want to talk about um, an aspect I feel doesn't really get much of an attention out there, and it's a feature that is included in Fusion 360 that really don't get utilized much, that gets overlooked, and it has a lot to do with the internal features or internal geometry of a shape or a profile we want to cut, right? Okay, so let's get right into it. First, there will be two kinds of profile I'll be talking about. First, I'll be talking about a profile that was designed on another CAD software like SolidWorks. Then the profile was exported as a DXF file. Um, the profile was converted to flat pattern, then projected for the sketch to be exported as a DXF file. Now the DXF file is imported into Fusion 360. A lot of people prefer programming their CNC machines, be it plasma, waterjet, laser, using Fusion 360. I believe due to its dexterity. Even for me, it's what I use most of the time at work, at Innovate, and it's quite handy. So first, let's get right into the first profile now. This design right here was first designed on SolidWorks, and then it's now it was exported as a DXF, and now it's being imported into Fusion 360. All right, so this is what we have right here, looking at it from the top view. Now, I believe my assumption is watching this video, you already know a thing or two about design in Fusion 360 or any other CAD software. So I would not really delve much into how to make sketches, how to make profiles, how to draw. I would just talk about the manufacturing aspect of Fusion 360, programming profiles, converting them into G code, that's post processing, converting them into G code for the CNC machine. So from this is the design window on Fusion 360 where you can edit your sketch, where you can modify, you can extrude, you can do quite a number of designing on this window, but that's not what we want to do today, right? So I come to this design tab and I change it to manufacture. Exactly. So in the manufacture section, we can see a lot of different subsections or tabs. We see if we want to perform a milling operation, a turning operation for lathe machines, additive manufacturing, inspection. But what we want to do is fabrication. So this has to do with if you want to cut using plasma, laser, water jets. It's under fabrication that you want to do this, being part of subtractive manufacturing technique, right? So the first thing is to set up our profile. So we click on setup. Now, right here under the setup tab, there are quite a number of things we have to take note of. Immediately we click on setup. What we are trying to do is that we are trying to tell the CNC machine that this is the stock we want to work with, the length, breadth, and the height. This is the stock we want to work with, and this is the origin of the stock. That is what the setup deals with. So first we come under the setup tool, and also under the setup is where we actually select the machine we're trying to use, be it milling, be it, sorry, rather, that's wrong, be it plasma, be it laser or water jet, but we'll be working with plasma, of course. Here in the setup section, we state our stock, our boundaries for the cutting operation. It's here that will give value to um, the stock we want to cut from, which is the length, the breadth, and the thickness of whatever material, in this case, a metal, which we would be cutting from. It's important to state here first the kind of operation we want to do. Now, for what you see here in this machine section, you can ignore. For now, it's just to try to have a view of what the, if you have a print installed machine in your workshop, probably it's on the list here in the Fusion library and you want to select. So, but that's not what we want to cover today because of our time, so we can ignore the machine aspect. We don't really need to select it. Now, operation type, we want to cutting as our operation type. Now, our orientation is always important. And the first thing I would always say is when performing in CNC setup operation, you should make sure, but it's still determined by the axis of your machine. But most machines I've come across are always having their axis vertical. So in your setup also, you should make sure your Z axis, look at that, is always vertical. Your Z is pointing out of your profile, of your flat profile. Your Z axis is vertical, and then the normal Cartesian coordinate, that's your Y axis, pointing towards the north, and your X axis pointing towards the east. So that is for the model orientation. Now, X, X, Y, and your Z pointing out. So it says what coordinate your model orientation. You can choose Z, X plane axis. Now you can, for these selection, it's just telling you whichever axis you want to change to. But let's just stick to model orientation. Now, origin. We already have our stock. I would also like to mention here an important point. Now, at times you will be working with profiles or shapes whereby the stock, the default stock, sometimes when you launch your setup, the default stock might overlap or might offset your material. In fact, sometimes it actually, um, shrinks below what your material actually encapsulate what it's the size, the actual size. So what you would do in that case, I will show you very soon. But first, I would always advise for you to choose two options. The first option is where you want to select your origin, and the origin is where do you want the machine to, where do you want to select the tool, the nozzle of the machine to be placed as an origin before it starts cutting. Now, I always select the um, left down corner, yeah. So for the Cartesian coordinates, so I always select that as my origin. So if you click on it now, it says here origin stock box point, which means you are selecting a point out of the points given on the stock. The stock is the yellowish gold or whatever. The color you're seeing is the stock. So if you look at it, that's the stock. The real profile is what you have there, your design. So now you can select the point in the stock as your origin, since you've already stated that that will be your stock. Now you can change this to a model box point instead of stock box point. Sometimes if you have your stock overlapping your design, you can select a model box point. Now, most times your stock should have a length and breadth of the extremes of your profile. You can determine that by measurement. You can just measure the extremes of your profile, the length and breadth, so you can know, okay, what scope can you, what measurement, what dimension can you give your stock. So, but in the case whereby you have a situation whereby the stock is like seems bigger than what you have as a profile, you can select model box point, and if that will be the case, it's going to bring some point at the vertices or corners of your profile. But let's stick to our stock box point. So I've selected, you can select anywhere, and then from there, I don't want to go into the details of this one much, but also you can change the direction of your Cartesian coordinates, which you see now we have the x negative direction and the z, but this is not advisable. So I always. Now, if you notice, the orientation has changed. It's saying x and y axis. So the z has turned upside down. Now this is top, right? You can notice that this is top, but and initially the z was pointing upward out of our profile. But if you look at what I'm going to show you right now, you'll notice the z is now pointing downward. It's pointing the opposite direction of our profile. So which means by the time your machine wants to start cutting, it's going to start cutting from here. So the opposite direction of the profile. It's going to start cutting from the bottom because that's where it sees as your z, right? So let's just go back to the top, back to the top, back to the top. Yep. And then selecting our model orientation. Now we have our Z, right, back right, where we want it. Good. So from here, now our model, of course, is our sketch. Selected it. Always remember to select your sketch as your model. Then we'll come to the stock. Now already we don't need to change anything here. The stock is already stated by Fusion automatically. Just measure the extremes of your profile and then just determines the stock from that. For instance, the extreme for this design is from here to here. We can see is 561.839, right? The distance, the extreme. Now, if you close this, if you notice our, that's it, 562, our x, the extreme is 562, so it already compensated for that. So you notice it's already measured what the x should be for the stock automatically. You don't need to do that, but sometimes it doesn't do that. It does it wrong, so you have to edit it manually yourself. Your stock has to overlap, even if it's just by a millimeter. It has to overlap your profile. Let's measure for our y if we can. I'm not sure. We have 603, right? 603.8 or 604, and here we have 604 for the y. You see, so the stock is already in good shape. So the one you most likely to always edit is your height. Your height is the thickness of your plate, the plate you're cutting from. It quite matters a lot because it determines the retract height, the cut pierce height of the nozzle, and it affects. So here we are cutting from 1 mm, so we put 1 mm. Now if you notice the height has reduced. If I select 9, the height has increased. You notice that? If I select 1 again, yeah. So, and you can save as default in case you don't want to always come back to that. For instance, if you have multiple profiles you want to cut from 1 mm, all these figures can be saved as default. But it's okay, it's okay not to save them as default. Always have time to edit your figures or let Fusion give the default values at first so you can edit them later on. And when we're done with this, we cannot go on with our processing yet. We have to pause on that. So when we're done with this, okay. Then after our setup and we are done with stating the parameters of our stock and our origin, which we did from the setup, then we come to our cutting operation. Here, cutting 2D profile. Now, the first thing to select when we want to cut is the tool. We come to the tool, select the tool. Now, here I don't have any tool installed. I want to show you how to go about installing the tool. So come to local library. From here, you can add to your local library and to your up library. Now, first, the first thing is to turn on your Fusion library. Turn on all Fusion libraries because by default, Fusion 360 has all the tools, virtual tools you will be needing for your operation, CNC operations. So when you turn it on, then you can see laser cutter, plasma cutter, water jet in inch and in metric. So I'm going to go for plasma. For metric, that's what I'm going to be using. Now it has, I'm on Fusion Library right now. So it has all these parameters stated, but you can edit them if you want to. You can always edit. So you can cutter here. I think this is okay, cancel. There's a point you can edit it. So you can, in case your nozzle diameter is different from what Fusion has. So For instance, if you have a nozzle diameter smaller than 1.5, probably 1 mm, you can always edit. Always remember your kerf width. Your kerf width is the space of cut. When your plasma is making its cut, your kerf is the cut part, the space. And it's determined a lot by your nozzle diameter. So plasma cutter. Okay, from here you can, add to your library, your local library, and then you can, okay, yes, this is where you can edit your nozzle width. So let's say your nozzle diameter, you have okay, 0.8 mm, then your kerf width. Now your kerf width should normally be bigger than your nozzle diameter normally. The reason is because your kerf width is your space of cut. When the plasma makes the cut, that groove is your kerf width. That cut part is your kerf width, which of course will be determined by the diameter of your nozzle. So sometimes it's bigger than diameter of your nozzle. So I'll name this default. Default. So order description. I don't need to go into this post processor. We'll come back into this later for the post processor. So yeah, let's save this. Now we have one in our library, local library. But let's stick to what we have in our plasma library. Create hub library. You can create your hub library for you're working in a hub, so that you can always use the same tool across you and your mates. You can always use the same tools across platform. Okay, let's go back to Fusion now. Metric select. So we've selected our tool. Cutting mode should be true. We want it to cut through. Now, one thing I would like to talk about here is when you are cutting through CNC Plasma, most CNC Plasma machines, and you're programming on Fusion 360. Now, I'm talking specifically concerning plasma machines because that's the experiences I've had. Now, these parameters, the feed rate, leading, lead out feed rate, is good if you want to state them here, but I want you to know that they are most times overwritten. They are overridden rather most times by the plasma machine, which means whatever values you set here later on the plasma machine, it's possible that that value will be overridden. It's what you set on the plasma machine that stays, that sticks. Good. Now our geometry. Now this is where we are going. So now notice that we have quite a number of profiles here. Now, like I've said in my previous videos, when you want to make any cut, when I was talking about the ship library for plasma machines, and you want to program for your ships, you should always make the internal cut before the external cut, which is quite very important. Make the internal. Now here we have quite a lot of internal profiles, very much a lot of internal profiles. So these are the internal profiles, these little dots and circles you see here, you see here are the internal profiles. Now this is the external profile, which will be cut last. Imagine if you cut this first, then the plate drops through on the plasma bed. How are you going to cut this? It's going to offset. So you cut the internal profiles first before the external profile. Now I am going to come here and do this and do this and do this. Good. Now I want you to look at this tree, design tree, or let me call it manufacture tree for now, and observe what you see right here, right? Because we're going to make a comparison later on. Now we have our sketch. These are all sketch, and these are named views: top, right, front, blah blah blah. If I click on the top, we are on the top. The front, so it's, let's go back to the top exactly. Now, let's proceed with our sketch profiles. We have to select what we want to, the contour selection, the geometries we want to cut. First things first, we select the internal profiles, internal geometries. And we do that by selecting the sketch itself, the profile itself. Now I want you to take note of something also. If you notice, immediately I clicked on the first internal geometry, there is a red arrow that pops up pointing downward. Now, I don't really want you to focus your attention on the direction of the arrow or where it's pointing. That's not our case. But what I want you to focus your attention on is the position of the arrow. Now, this is the circle we want to cut, and this is the arrow inside the circle. Now, watch this. If I click on the arrow, it comes outside the circle. Now, for all internal geometries, the red arrow must always be inside the internal geometry. whatever shape the internal geometry is. It might be a star, a square, a rectangle, a circle. The arrow must always be inside. Now, the direction, like I said, does not really matter. I don't think I really memorize what the direction should always be, but what I know is that the arrow must be inside. What this means simply is that you're telling the plasma to always lead in the cut of the internal geometry from the inside the circle. I'm going to talk about leading and lead out later on. I've talked about it in my previous videos. Now, this is just saying that I want you to lead into this cut from inside that circle. Now, if you put it outside the circle, that means it's going to lead in from outside the circle, and it's going to affect your main profile, your main body. This is the main body of the cut. Here is the main body. So you have to bring the arrow inside and lead in. That is one. Then secondly, what this means is the part of cut. You are telling the nozzle, the CNC machine, to make sure that the nozzle is moved in a way to compensate for the size of the circle, which means when it's going to take in consideration the kerf and the kerf width. Let me just talk about the kerf width, so as not to cut this hole too big. It has to make the compensation from inside the profile. So by the time it's done cutting, the hole will be the same as you have in your design, the same diameter or the same perimeter, the same size as you have in your design. If you put it outside, rather, it's going to make the compensation from the outside, thereby making the size of the geometry bigger than what you have in your design, what you intend for it to be. So you have to always make it inside. The arrow should be inside your internal geometry, so it can compensate from this for the size from inside the geometry. That is that about that. So we go on like that, and we go on to select everything. Now it's inside. Again, let's see, it's inside. Good. It's inside. Now there are times whereby you're selecting your geometries and you click on the internal geometry or any geometry twice. This is what happens when you do that. This chain dialog box pops out. Now what you need to do is just to click on cancel. Sorry. Yeah, cancel. You don't need that. So select this, select this, select this. They're all internal. Don't worry. They're all internal. I'm very sure of that. Select this, select, 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 and select. Oh boy. Oh, thank God. Now, I know what is going on in your mind right now, that why can't we have a feature that will select all the geometries for us at once? Well, there is a feature that does that. It selects all the geometry at once. And I'm going to cover that in the next design. So for now, I am just showing you if you want to select the profiles one by one. And another thing I mentioned in my previous videos is if you have multiple internal geometries of different sizes, always cut the smaller sizes first before cutting the bigger ones. If you have internal geometries that is, you notice that the internal geometry are quite different in sizes and shapes. Imagine if we have these circles and we have them in different sizes and different shapes. Always cut the smaller ones first. Cut the smaller shape first before the bigger ones. So which means in that aspect, you have to select them manually. You select the smaller ones first, then you select the bigger one. Now we are done with the internal geometry. Now we now select the external geometry as the last one. Now, of course, the arrow has to be outside so as not to tamper with our main profile. So when it wants to lead in for the external geometry, it leads in from the outside of the external geometry, and also the compensation for the cut is from the outside of the external geometry, so that our main profile remains intact, remains in shape and size that we want it to be. Now, since we're done with this, I can close all this and show you how to select them at once. So you don't need to go over selecting one by one, one by one. Now remember, I told you that this design was made on SolidWorks and then imported as a DXF into Fusion 360. There is a feature that is meant to be here, but it's not here. The feature allows us to, select geometry specifically. Now, for us to select all our profiles, all our geometries at once, what we need to do is click on the sketch profiles. Now if I click on OK, now you can see how randomized the path of cut is. It starts from here first, or sorry, it starts from here, the internal profile first. Now if you notice, it's cutting from the inside, and you can see there is a leading from the inside. So it leads in from the inside and goes about cutting the internal geometries, then cuts the external geometries. But it's quite too randomized. Now I can come on edit and select the sketch profile and do something. Now initially when the sketch profile was selected for the cut, it remember how we selected the sketch profile is when we come to geometry, we just select, we come here under the manufacture tree and we select sketches, right? Now you can double click on the sketch profile and it says start from outside, right? Now if I select start from inside and I click on OK, I click on OK, I will show you something. Now notice that the leading comes from outside, thereby affecting the main body of the cut. Now the stock in the middle of the circle is untouched, but the leading starts from outside, and this will actually affect the diameter of this profile, the size of this profile after cutting. The same thing happens to the external cut, I believe. So the leading comes from the main body. Look at this. The leading comes from the main body of the cut. So that is just what I want to show you concerning when you are using the sketch profile. Or you can just use the initial method by selecting your profiles one after the other and making sure the arrow for the internal profiles are inside and the arrow for the external profile are outside. So that's for that I will stick to start outside. For the sketch profiles, remember I selected all the sketches at once. Now after we're done with the geometry, we come to the clearance height. Now I would always advise that you leave these parameters as they are. Fusion 360 sets these values on its own, and I believe it knows what it's doing. So now when we talk about the clearance height, the retract height, and the top height is always from the stock top. That's the height of the stock. I normally would delete the settings. Just that's the summary. Now the passes. For the passes, first the tolerance should be left as it is. I won't talk much about that. I really don't deal with that. But for the compensation is what I want to talk about, the compensation. Now, remember when I told you about making sure the internal profiles have their arrow selection in geometry internal, right? Now, it is because of this compensation called sideways compensation when cutting. Look at it, it says it determines how to offset the cut from the selected edge. So this compensation is important to always consider when selecting your geometries and profile. Now here it says select from left. That is why when I selected the internal profiles initially and the red arrow was inside, what it means is that it is going to compensate from the left. Now the left is where the arrow is pointing downward. Now since the arrow is pointing downward, so it's going to select from the left hand of that arrow pointing downward, which is your own right hand looking at the screen. So it's going to compensate it internally. Do you understand? Now, you should never select center because it will compensate both left and right, which means it is going to cut into your main stock. For instance, the internal geometry, by the time you select left and right, is going to cut into the main stock and alter the final size, making it a bit bigger. Also, you can either select left or right, but make sure if you select right, make sure that your arrow for the internal geometries are inside the internal geometries, and for the external geometry, they are outside the external geometry, whichever you want to select for left or right, but avoid center. So that's for the compensation I was talking about now. Compensation type should be left as in computer. Finishing overlap, we can leave all this now. Preserve order. Preserve order is just a term that says that when for instance, initially when I selected all my internal profiles manually and it shows the red arrow one by one. So the preserve order means I'm telling the machine to make the cut in the exact manner and in the exact order I selected those profiles, which means if I selected this first and then the second one I selected this, the one at the top, that is how the machine is going to make the cut. It's going to cut here first, then cut here. If you remember the initial one, I selected this, then selected this, then selected this. Then that is how the machine is going to go all around, cutting them the exact order I made the selection. But if I remove this preserve order, the machine is going to try to optimize. Fusion 360 is going to try to optimize my selection, the G code, and try to make sure the selection is as close to each other as possible. But I always like using preserve order. I sometimes I make my selection based on discretion, just because I know the kind of material I'm working with, and I want my cuts to be made the exact way I selected them. Stock to leaf. No, we avoid this. We do not need it. Yeah, we do not need it. Smoothing feed, we don't need all these parameters. Then linking, keep nozzle down should not be selected, because if you keep nozzle down, it will affect your movement of the nozzle because of slags. Sometimes you might be dealing with a very light material and slags builds up on your nozzle. This might cause your nozzle to get stuck along the way. Now, lead in and lead out. Leading is just a parameter whereby you are telling the machine to start the cut from a point and leading into your main cut. That's just what it means. It's as simple as that. You can state the radius, the angle, and the distance. So most times I lead in, but I don't lead out for my cut. So immediately I'm done with my cut. At that point, the nozzle stops. So this the lead in, lead out is just blend into the part of the profile, like it says in this definition. So, but sometimes we have issues whereby, for instance, this cut I'm trying to make has a very small size. The diameter is quite small. So in those cases, sometimes you have to remove your lead in and your lead out. So, but it's a very rare case. It's actually a very rare case, quite very rare. If you are having trouble setting up your 2D profile, just look into your lead in and your lead out. You can always remove them. It's not always compulsory to have them. Then lastly, the preferred leading position. Sometimes you want to select where you want to start your cut. You just select a point, you select that leading position into the cut. From here, we can say we are done with our setup for our profiles, our sketch profiles. We are really done with our setup. But before we go, I would want to show you if we had selected the profiles one after the other. So instead of having a randomized kind of cut, we'll have a smooth cutting path and selection, which we are going to see in a bit. And there we go. Do we have everything internal? Yeah, they're internal. And we select the external. Now this is selecting inside the external cut. You have to bring it outside. Good. Now it's outside the external cut. Now if I click on OK, yep. All right. Now look at how smooth that is, because I selected preserve order. So it just goes along the path I selected in the same order I selected it. Now we can tell it to simulate, right? Okay, now watch this. It's going to start from the internal first. See, so it cuts through the internal first, preserving our parts, the parts that was selected, preserving that part. I can make this go a bit faster. Yep. So you can see after cutting through the internal features, it comes out to cut the external features, and it is done. That is exactly what we expected. That is what we wanted. Now we exit simulation. Now from here, when you're done simulating, then you come to what we call post-process. That is what turns your program into your settings, your setup into the G code. Now you can see down here at the right hand side corner, downward, you can see your machining time, the time it will probably take to cut this piece. Sometimes, most of the times, it's quite accurate, actually, from experience. Now I've clicked on the post process and I am here in this dialog box, and what I am going to do is to first select a post processor, which is very important. Post processors are what will allow us to be able to convert it to the G code. Now, if I post right now, if I post, it's going to bring an error because we don't have the post processor selected. So what I'm going to do is select post processor. I'm going to go to my post local, and I'm going to import a post processor. Now, post processors are everywhere right there in the Autodesk library website. There are quite a number of post processors. You can just search it on Google. Post processor for either plasma, laser, water jet, additive. There. So this is a flash cut plasma post processor, CPS, is exactly what we need. So another thing I should show you is, okay, let me import the second one. This is for milling, by the way. So I have two post processors, one for milling, one for plasma. Now you cannot use the milling post processor for a plasma operation. Let me show you. Now if I try to, now this should be bottom body or thereabouts, body from 1 mm times 1. All right, now if I try to post-process this, let's say I'm post-processing into document. If I try to post-process this, I'm going to see a field right here at the bottom right-hand side corner, right? That means I'm using the wrong post-processor. So instead, what I am going to select is the plasma post-processor, and I'm going to select the folder I want to post-process into, right? So, right. Okay, that should be it. Sorry, bottom body, 1 mm, just one piece. That's one piece. Now, if I post, you see successful. Now you can view your NT code if you have a note editor or you have a Visual Studio Code recommended. So most of the time, the program just launches your Visual Studio Code automatically. So, but here I'm going to stop it from downloading Visual Studio Code because I don't need it. But you can use it to view your G code. Now that's about this profile, this design, this cut, and we are going to take it to the machine and cut, and you're going to see it's going to cut through the internal features first, then cut the external features, external profile last. And then later on, we are going to go through the second type of profile that can be faster in processing, in programming. Thank you all for sticking to now. See ya.
All right, everyone. Right now we are going to cut a new file. We go into our USB, navigate into our folder, and this is what we want to cut. Right. Since I'm cutting from 1 mm, I believe a cut speed of 2000, or rather 2800 should be enough. And all these parameters has been set. I would like to, okay, 100, it's okay. This should be around 3, 4, 4, 3, 3, 6, yep. And the hard volts right there on 30, arc current, rather, arc current. And right there, my minimum plate, can pick my origin. Okay, I think that's enough. Then I free. Well, framing speed might be a bit slow, so I increase the speed. Bring the nozzle down to trace out my shape. Okay. Alright, I think that's okay. It's right at the tip. Love conserving the material, avoiding wastage. And right there, we can, of course, fire goes to cut the internal details first. This is not really okay. But we'll manage it. Just for this cut, we'll manage it. Now, look at this. It is wrong. That's what you get when at the times the nozzle is weak, the plasma is weak, and you have too much speed. So here, come here from 2800 and reduce to 2500. Yep. Then backward. For the width, alright, you can start from here. Well, what I resume from there. Okay. And there we have our cut. Now it goes back to origin. Escape. Now go shape. Quite a clean cut. Minimum amount of carbon slack. And what we have here. See you guys in the next one.